Hello guys, this is Mr. Gloria and welcome to another algebra video tutorial. And today we're gonna be working about graphing absolute value functions. And in line with this, we're going to discuss the properties of an absolute value function, such as the vertex, the axis of symmetry, the minimum or maximum, the domain, and the range of a certain absolute value function. But before that, let us go ahead and review what does absolute value means. Absolute value of a number means. Absolute value of a number is simply the distance of a number from zero. Okay, how far a certain number is from zero. First one, the absolute value function is written as f of x equals absolute value of x. We call this as the parent function. Okay, parent function of an absolute value function is f of x equals absolute value and then x inside. Now, looking at the table here, the graph or the grid, and then the properties. Okay, so if the absolute value of a number is the distance of a number from zero, let us identify the absolute value of each x value here and complete the table. So let's start with zero in the middle. The zero is, of course, zero distance away from itself. Positive one is 1 unit away from zero. Positive two is 2 units away from zero. Positive 3 is 3 units away from 0. And so is with the negative values as well. Negative 1 is 1 unit away from 0 on the left side. Negative 2 is 2 units away from 0 from the left side, to the left side, I mean. And negative 3 is 3 units away from 0 to the left side. So now that our table of values is complete, let us plot those points. Starting with 0, 0 right here, 1, 1, 1, 1, 2, 2, 2 and 2, 3, 3, 3 and 3. With the negative values of x, negative 1, positive 1, negative 2, 2, negative 3, 3. Okay, then let us connect our points. Boom and boom. Okay, looking at the graph looks like a V shape. Okay, a victory V shape. Okay, from the given graph, so as the given table, let us identify the properties. First one is said to be the vertex. The vertex is the turning point. Okay, so it's right here. Boom, and that point is the point. Oops, my bad. 0, comma 0, and from the table, it's right here in the middle. So meaning your vertex should be in the middle of the table. Okay, again, that vertex should be in the middle of the table. Okay, moving on to the axis of symmetry. Axis of symmetry is where the graph is cut or divided in half. Okay, so we're going to draw a vertical line, okay, across this right here. Okay, so this line cuts the graph in half, and that value of x, okay, so it crosses that vertical line crosses the x at 0, so x equals 0. Well, in fact, the axis of symmetry okay, is simply the x value of the vertex. Okay. All right, now moving on. Is it a minimum? That's what min means in here. And for max, it's maximum. Is it minimum or maximum? Now let's look at the vertex. Is the vertex the lowest or the highest point of the graph? In this case, our vertex is the um, the lowest. Let me okay. Again, this vertex right here is the lowest point. So since it's the lowest point, then we say it's a minimum. Okay, and minimum, that y value of the vertex goes here. Y equals 0. So minimum at y equals 0. Now, domain and range. Let's start with the domain. Okay. Our domain, since there are arrows in each end, so that tells us it's not going to stop. Okay, it's going to keep going and keep going and it goes. And that means our domain or the x values are all real numbers. Okay, remember that symbol for all real numbers. Okay, you can use the symbol or just write the word all real numbers. Then for our range, looking at the graph kind of here, right? The graph uses the grid or the points wherein it's above the y equals 0. There are no points, there are no part of the graph that is below y equals 0. So that tells us y, the range, y values of course, oops, alright, y must be greater than or equal to 0. Okay, so there you have it. We have our vertex, axis of symmetry, a minimum in this case, domain, which are the x values, and the range, which are the y values. And in general, okay, the graph looks like a V shape. Okay, and the turning point of the graph is called the vertex. Okay, so that's how we identify the properties or the attributes of an absolute value function. Okay, so if you look at the steps here, I'm going to move it up. Graphing by table, I just showed you that. Okay, now the steps are find the x value first, so we know what goes in the middle of the table, and then we're going to complete the table. Then after that, we're going to plot the points, connect, and identify the properties or the attributes of a given function. Okay, let's look at example number one. This time, we're gonna combine doing it by hand and the use of TI and Spark calculator to save time. So, step number one, find the x value of the vertex. The term inside the parentheses, oh, absolute value, my bad, is x minus 4, and we're gonna equate that to 0. Now we solve for x by adding 4 on both sides. So now x equals 4. So we know that x equals 4 goes in the middle of the table, right? Let me use the black right here. Okay, then let's complete the x values. 4, 5, 6, 7. The number above it is 3, 2, and 1. Okay, so like I said, we're going to combine doing it by hand. We did the x value by hand. So now let's go ahead and jump into our TI and Spark calculator. So to graph, we're going to go to the second page or second document, which is add graphs. I'm going to click here, and we're going to type the absolute value of x minus 4. For the absolute value, we're going to click here. Um, we kind of call it like a library, that key next to 9, our library. And notice that there's a fraction, exponent, square root, cube, nth root, and so on. And the absolute value is right here. Okay, click on the absolute value. Now you see that there are two bars and the blinking cursor inside that. So go ahead and type x minus 4. Let's hit enter. So that gives us the graph of the given absolute value function f of x equals x minus 4. Now we need to go to the table of values. So that way we can get the values that goes on the y column or f of x column. To do that, we're just gonna press Control T, the letter T. T, which is stands for table, of course. Control T. Notice that it starts with 1, 2, 3, 4, and so on. But we want the x equals 4 in the middle of the table. So let's go ahead and adjust that by pressing Control, or I mean, by pressing arrow down. So notice that 4 is now in the middle. Okay, so 4, 0, 5, 1, 2, 6, 2. On the top, 3, 1, 2, 2. And of course, if you go one more up, 1, 3. And on the bottom, 7, 3. Notice that I see some type of symmetry in here. Okay, 1, 2, 3 above 0, 1, 2, 3 below 0. Now, let's plot the points. So 4, 0. So from here we go 1, 2, 3, 4 to the right and plot the point. Then we have 5, 1, 6, 2, 7, 3. And on the left side, we have 3, 1, 2, 2, and 1, 3. Again, in general, it looks like a V shape. So let's go ahead and connect the points. 1, 2. Okay. Making sure that there's arrow in each end of the graph. Okay, so let's identify the given vertex. What is the vertex of the given graph or function? So from the graph, it's right here. Okay, that's the turning point. Okay, and from the table, it's the middle of the table. So our vertex is at point 4, comma 0. Okay, axis of symmetry, it's a vertical line at which kind of cuts the given graph in half. So notice that you cross x equals 4, which is the same thing as the x value of the vertex, so x equals 4. Now, minimum or maximum, again, it's either the lowest point, is the vertex the lowest point, or the highest point, in which in this case, it's the lowest point. So, we say minimum at y equals the y value of the vertex is 0. Okay, so two more properties, the domain and the range. Domain are the x values. And like I said, whenever there's arrows in each end, we know that the domain should be all real numbers, or that symbol for all real numbers. Okay, now for the range, let's go ahead and kind of highlight the whole graph right here. So all the graphs are, like I said, above a certain point, and in this case, that's above 0. Okay, So above 0, there are no parts of the graph that is below 0. So we say that y is greater than or equal to 0. Okay, so that completes the graph of an absolute value, which is absolute value function, which is f of x equals x minus 4. And we were able to identify the properties, the vertex, the axis of symmetry, whether it's minimum or maximum, and identify the domain and range of uh, the absolute value function. Okay. All right. Moving on to number two. A second example: absolute value of 2x plus 6. Okay. So we're going to use the term inside the absolute value symbol, which is 2x minus 6. We're gonna equate it to 0 and solve for x. So plus 6 on both sides. Oh wait, let me make correction here. It's not minus, but it's plus. So 2x plus 6 equals 0. So minus 6 here, minus 6 here, cancel. Then now you have 2x equals negative 6. Then divide both sides by 2. X equals negative 3. Okay, so that negative 3 goes in the middle of our table. Boom, negative 3. Then we have negative 4, negative 5, and negative 6. Then below, negative 2, negative 1, 0. Okay, now let's complete the table by typing the given function in the calculator. So go ahead and press Control, Document, and we want to add graphs. So absolute value symbol goes right here, and select the absolute value. Then type 2x plus 6 inside, hit enter, and there's our graph. I'm going to move the label below. Okay, now we need the table of values. Control, Table, Control T. Now if you press Control T one more time, you're going to hide the table. To show the table one more time, Control T. Okay, then negative 3 should be in the middle of the graph, or the table, my bad. Negative 3 right there. Okay, so now let's go ahead and get the values of the points above 0 or above the vertex. Okay, negative 3 is 0, so 2, 4, and if we go one more up, 6. Now, like I said, it should be symmetrical, so we have 2, 4, and 6 as well. Now our table is complete, so let's go ahead and plot the points. First point is negative 3, 0. From 0, go to the left side, 1, 2, 3, negative 3, 0. Then we have negative 4, positive 2, negative 5, positive 4, negative 6, positive 6. On the right side of the vertex, negative 2, 2, negative 1, 4, and 0, 6. Okay, now connect the points. Okay, so that's pretty much the graph of f of x equals 2x plus 6. Okay, now identifying the properties. Okay, what is the vertex? So our vertex is right here, okay, and also right over here in the middle of the table. So our vertex is -3, I'll put it down here, comma 0. Okay, axis of symmetry. Okay, so let's go ahead and draw our vertical line that will cut or divide the graph in half. So boom, 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 boom. Okay, so passing through that vertex in which x equals -3. Like I said, that axis of symmetry is simply the x value of the vertex. X value of the vertex. Okay, now minimum or maximum. Is the vertex the lowest point or the highest point? And like I said, in this type of function, it's a minimum because the vertex is the lowest point, and the lowest point of the given graph is y equals 0. Okay, now for the domain and the range, and since there are two arrows in each end, so the domain will be all real numbers. Okay, and the range, okay, let me highlight the whole function again, which is right here. So all the points are above the y equals 0, so therefore the range will be y greater than or equal to 0. Okay, so that completes the graphing the absolute value function graph of f of x equals 2x plus 6 and identifying the properties, the vertex, axis of symmetry, minimum or maximum, domain, and the range. Now, in some cases,
Yeah, I make decisions to glow. Ridiculous flow, potential to glow.